in our sprite animation, I have now 8 separate PNGs that represent the different animation frames of my little green character, alien 0001 through alien 0008.png. To work with that and to animate it, we need to do a couple of different things. We need to know how many sprites we're dealing with. So it's 8, which corresponds to the 8 images that were exported. And we're going to have our current sprite, as we're going to be able to loop through our set of images. We'll start that out at 0. Now, if we just want a single image to show up on screen, we need to have a pImage object, and then we need to use the image command, and we reference that pImage object, and then we give it an X and a Y location. So if I wanted a non-animated version of my image to take place, we could look at something like this. So if we have that image, and you don't need to do this, this is just for demonstration purposes, test equals load image, and then you specify what file you're trying to load. And all of my images in this case are 3 zeros and a number. So I specified test is loading that image, and then I could just simply say image show test, and then I could specify a location that I want to see it. Running that with my semi in place, we will see that it should show something. All right, so running that, after commenting everything else out, it draws the image. So when you have an image object, you populate that image object using load image, and then you specify the image file that you're loading, and then using the image command, you then specify that image object, and you give it an X and Y location. That's the simple construct for displaying an image in your project. One thing to keep in mind, and some of you in your attempts at using images have found that you let it run for a while and then you run out of memory. It gives the out of memory error. The most common reason for doing that is you have load image occurring inside your draw loop. So every frame of your project, so every time it loops through draw, 24, 30, 60 frames per second, it's now loading that image file into memory and reloading it and reloading it. And each time it does that, it chips away at the available memory for your program until eventually it crashes because it ran out of memory. That's one of the most common things, is to issue a load image command repeatedly when you don't need it. So I'm going to suggest that all of your load image commands should only occur inside setup, or when we build a class inside the class constructor function, not inside any of our draw functions, display functions. We should never be referencing load image repeatedly over and over and over, otherwise your project will run out of memory. Moving forward now, updating its static image, so it draws the static image on screen. We'll verify my code is not broken now that I move some things around. Okay, so it draws. There it is. He's just sitting there on screen, la-di-da, ho-hum. All right. Now, moving forward with that, we know that we have a total number of sprites or frames that we're going to be using for this image. And it's 8 because there are 8 images that were exported, 8 frames that were exported from our Sprite animation in Flash. We like to begin counting our animation at 0. That way we can take currentSprite and say 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. So we can keep looping through and figure out which of those images we want to see. Now we have this array that we're calling frames. And with that, we're going to take and put each one of these images into that array so that we can say, show me the first image, show me the second image, show me the third image, show me the fourth. Because if you remember when we built it last week in the chaos of dealing with sprites, we had image 1, image 2, image 3, image 4, and then we would have to say image, draw image 1, image, draw image 2. And that doesn't really work very well, and it made for highly repetitive, really obnoxious code. And if you had 100 frames in your animation, I wouldn't want to have image 1, image 2, image 3, image 4, all the way through image 100 variables that I'm putting. Yuck, that would ugly. So this way, if my sprite animation isn't 8 but is 800, that would be the only thing I would have to change in my code and everything would work here. So if I had 800 versus 8, the code would work by changing that one number. So that's why we want to use this method versus individually naming and loading each frame into its own identifiable object. Using the array allows us to keep track of the images, and then we will use the array to keep track of multiple copies of this. So now we can take this sprite that we have and we could go and put 100 of them on screen. Could put 1,000 of them on screen. And at that point, all we're doing is changing one number, and that changes it from 1 to 100 to 1,000. So our frames array, we're using our array constructor, so we say frames is equal to new, and then we have to specify the array is holding what type of objects, and it's going to hold our images. And our array is going to, we have to specify how big or long that array is, and we then will tie it to how many sprites. This way, it makes it much easier to have more flexible code down the road, and we will see advantages to doing it this way. I could have retyped the number 8 in here, but doing so, if I ever then wanted to recycle this code for an animation with 12 sprites, 16 sprites, 32 sprites, I would have to go and change the references multiple times, and that's just not very fun. So we don't want to do that. Now, using a for loop, we're going to cycle through the for loop, and a little different than most of our for loops, we start at 0. And because the files, when they were created, start their numbering at 1, not at 0. So we could go through and change all our numbers and make them all down by 1. So this would become 0, 1, 2, 3, 4, 5, 6, 7. So we could do that, and then we could start I equals 0. But the nice part about for loops is you don't have to start at 0. You can start at whatever beginning number you want. That's one of the advantages of using a for loop here. So we start at 1, and then we're going to create this temporary name, and we put it together so it's alien.png, and then we're putting in a number. We're going to format the number, NF, number format, and the number we're formatting is I. So the first loop through I is 1, but then we say 4. This 4 indicates I want my number to be 4 numbers long. So it will be 0, 0, 0, 1. So that number formatting is a way that when this loops, it generates 0001. The next time through will be 0002, then 0003. So it's a handy convention that processing has to format numbers. So I can say NF with number format, how many numbers long I want it to be, and then it puts, you know, this number in that format. That's what NF does. Unless you're building an animation longer than 9,999 frames, you can use this untouched. If you build an animation that long, you didn't use Flash, because Flash typically will go belly up around 5,000. So, and if you're doing that, that would be loading 9,999 images into memory, which means it would probably cause processing to go belly up as well. So then we would need to come up with a different strategy for dealing with our images, which there are ways we could do it, but it would be uncommon to make something requiring that many images. So leaving this untouched, NF parenthesis I comma 4, knowing that our software generates a number with 4 numerical characters, 0, 0, 0, and then whatever the number is, means this will work in most instances. If your file is not called alien but is called something else, then you change that word here to match the naming scheme of your file. Line 17 is going to take each position in the array starting at 0, because if I starts at 1, I minus 1 gives me 0, and then we're telling it to load image, and the image we're telling it to load is temp name. Now we can see temp name is here. We could get by without having this temporary name variable and just put this code directly inside the load image parentheses, and it would work. But for readability's sake, anytime you start having something inside parentheses, inside parentheses, inside parentheses, and all kinds of extra functions and helper functions and other things and putting it together, typically what it does is make your code a nightmare to read. I believe that assembling it this way, where we use this temporary variable of the string, and then we're saying that's the name of the file I want to load, by separating it out into its own line makes it a little bit easier to understand. Now, if you wanted to rename temp name, you could call it even something like file name, like that. So you could say, this is the file name, it's alien000i.png, and then that's what we're loading here. So then that takes care of loading each frame, each position in my frames array with each one of my images. That's what this for loop does. All right, wrong key. The next thing is that we need to say, I want to show that image, and I want to show frames currentSprite. currentSprite starts at 0, and that means it will grab the first image that was loaded into frames. Let's see, and I'm going to make it both of these the same. So alien0001 was loaded into the first image of my frames array. So I'm going to say I want to see that image, and it will show it to me at the mouse x minus 35 and mouse y minus 20. So if we look at that, we will see there it is. It is indeed the same frame of my animation, so it's now loaded it. My animation is not looping because currentSprite is not changing. currentSprite is set to 0 right now, and I'm not updating, changing, modifying, or doing anything to it, so it's just there. Now the mouse X minus 35, mouse Y minus 20 is to offset the position. Otherwise, the top left corner of my image would line up with the point of my cursor, of my pointer. And I don't want that. I want it moved over. So we can just get rid of those and see.
Why isn't the other one shown? Oh, on mine they...
I'm going to come back to the line that's commented there, but just to show. So if we choose currentSprite, and if we just tell it to get bigger, we could use the plus plus, or I could use just plus equal 1 there. So that will know the next draw loop, currentSprite was 0, it becomes 1, then it becomes 2, then it becomes 3, then it becomes 4. Now the problem with this is it's going to run into a problem that when currentSprite is more than 8, then I'm going to get an error message. And it does that very quickly because that's like 1/3 of a second, which is why the error message came up right away. And I'm getting out of bounds exception because currentSprite is now more than my total number of sprites, which then means it failed. So one way that we could write this in longer code, I could say if currentSprite is less than total sprites, then we make currentSprite bigger. Else currentSprite is equal to 0. So when currentSprite is 7, that's less than 8. Now currentSprite becomes 8. I believe then we need a -1 here. Well, let's try it. So when currentSprite is 0, that's less than total sprites, that's 8. So now currentSprite is 1. Now when we get up to 7, because currentSprite really needs to be 0 through 7, because arrays start counting at 0. So when currentSprite is 7, 7 is less than total sprites. So then it would add 1 to it. So this will generate an error message as well. We can run it and see. And we get the same error message, which is out of bounds exception. So if we do a -1, so when currentSprite is 6, 6 is less than total sprites -1, which is 7. So it runs and makes currentSprite equal to 7, but 7 is not less than 7, so then that would reset it to 0. So we can notice now we get the little swimming guy chasing his friend who is apparently frozen in time and is unable to move. So this is a common way that you can create that loop of currentSprite less than total sprites -1, currentSprite plus equal 1, else currentSprite equals 0. That's a common way to do it. If you like efficiency of code, this is a better way. And if you look at a lot of animation and game programming, you will see that my line 36, currentSprite is equal to parenthesis currentSprite plus 1 close parenthesis, and then use the modulus function with total sprites. So we're just now collecting the remainder value. Then that keeps currentSprite equal to 0 through 7, and that works really well. So it takes these 1, 2, 3, 4, 5 lines of code and condenses it down to 1. Now, if you use it and go, that's really cool, and a month down the road you're like, crap, what was that line of code? How do I remember it? You take a line like this and you put it onto your algorithm cheat sheet. So we have on your algorithm cheat sheet where you have some of your different trigonomic functions you need for, say, moving in a circle, moving on a curve using sine and cosine, calculating the angle between 2 points, arctangent 2. And then when you're trying to deal with sprites and sprite sheets, there's a couple of other formulas that we end up using for accessing them. And we just write those onto our little cheat sheet. We keep that handy of these are the algorithms. These are the formulas that I use most frequently. And we just put those into one place because chances are you'll forget it, but you'll remember that you knew how to do it. So then you just go find your cheat sheet that has that algorithm for you, and then you're good to go. And that would be a recommended course of action. So now I'm updating doubly, so then that's going to cause all kinds of headache. Comment that one back out. So these 5 lines of code work. If you don't want to use the modulus function because you're scared of it and math gives you heebie-jeebies and anything math related makes you freak out and run away screaming like a little baby from the classroom, that's okay. I'm okay with that. Then you can use the 5 lines of code and that works just fine. It's easier to understand. Moving forward, we want to now turn this into a Sprite class that we are able to use. So turning this into a Sprite class is going to require us to construct that class. So I'm going to go down to the end down here and construct that, but first I'm going to just get some extra return so I can be higher on screen. So starting out, making my class, I just say class. This is making a class. I get to name it. I'm going to call mine Sprite. And then curly brace, close curly brace. I have now constructed my class with it. I'm going to put a few comments in here to remind us of the pieces that go into a class. So the first thing that we have are our variables, our data that we're working with. The next item that we're going to have in our class is going to be our constructor. And following our constructor, we will have our methods. These are the things that our class knows how to do. These are the activities that it will know. It will know how to run, jump, walk, talk, sleep, breathe. The things that it's aware of. Well, this particular one is just going to know how to update its position and how to display itself on screen. So it's going to be a pretty wimpy Sprite at the moment, but it's a good beginning part. So every class needs these 3 aspects to it. There's really no reason to construct one if you're not going to have methods associated with the class. So every class you make, you will have your variables, you'll have your constructor statement, and you will have your methods. So we're going to start out with the constructor statement. And we notice that the name of our constructor statement, and it's written just like a function, but its name matches the class name. So when we want to instantiate or use a copy of this class in our project, instead of having an integer or a p image, we will reference it as Sprite. Because there is no pre-built Sprite class in processing, so we can use that as our name. In some languages, Sprite may be a reserved term because they have a built-in Sprite object, so we would have to come up with a different name that we wanted to use. Maybe it would be image sequence Sprite or something like that. So you'd name it appropriate to what it's doing. And now, the fun part here is as we're going to work with this and migrate what was a standalone sketch into a class-based sketch, most of what we're going to do already exists, which is pretty cool. So what I need my total sprites, current sprite, and frames variables. Those no longer are necessary for the main sketch. Those are going to be part of my sprite. So I'm not going to delete things, I'm just going to comment them out when I'm no longer using them. And at the end, I'll go and start deleting. But I like to, when I'm doing this migration process, to comment things out when I'm moving it. So I copied those lines of code. Then I comment out these old ones. Because then that way, when I'm going back and forth between the original sketch and the class that I'm building, I can see what was there in case I get mentally confused or I have a little brain stoppage where my brain just stops comprehending things and I need to go back and forth. So I copied those lines of code, total sprites, current sprite, and frames. I'm going to go into my sprite here, and those are now variables that are going to be part of this. Total sprite, current sprite, and frames. So that gives me a starting point, and we're going to have a few more, but we're going to work with the easy stuff first, which is essentially moving things over that we already have. So grabbing those three variables up there, we move them down. Now, inside my setup, where I gave total sprites, current sprite, and frames values, I am now going to move those to my constructor. So I'm going to copy those lines of code and move those over to my sprite constructor. So now inside my sprite constructor, I'm specifying total sprites, zeroing out my current sprite, populating my frames array with stuff. Now, the two methods that we are going to use are the two methods that we have been using previously, which are update and display. So with that, I'm going to have my update function, and then I will have my display function or method. Now, methods are functions. They're the actions, the verbs that this class is able to do. When functions are part of a class, they are referred to as methods. The things that that object knows how to accomplish, how to do. In this case, this object will know how to update itself, and this object will know how to display itself. The display information is actually contained or written already inside what was our draw function up here. So we have that information. I'm going to move this up so I can just do one copy. So I'm going to grab this display information, copy that, comment out the old one, and go into my class and paste it in. Now, we don't have anything occurring with the update yet, but we will start including that inside our item shortly. So we've now effectively moved almost everything from the main sketch, everything that was tied to this animated sprite, and we've put it into this section over here. Now, just need to move that over. So now we can see I have my variables, I have my constructor, and I have my methods of update and display. If you run the sketch right now, what you will find is your animated sprite disappears, and we're back to only seeing the static sprite show up, or static image, because that's all that's being commanded of our project. So currently we've now taken our animated sprite out of commission, but we will bring it back momentarily. I want to now see one of my sprites show up on screen. So I will call it Sprite S. s is equal to a new sprite. And the only method we need to call at the moment is s.display. And if variable, my type of object is sprite, matches my class. We create a new instance of that by new sprite. And then we call that sprite's method, which is display. So that will now run that function. Now if we watch it, we'll see that it's exactly how it worked last time. Now, one thing about this is that inside our Sprite class is hard-coded for the word alien. Some of you created your own projects where you did alien lowercase, or you called it green monster, or you called it something else because you decided to use your own artwork instead of the crappy artwork I provided to you. And I applaud that and say good for you. But what we can do is we can make this a little bit more flexible so that what we can do, instead of specifying inside the class itself the name, we can now specify that when we create a new sprite, I could say, well, I know that I'm going to use, that's the primary name, the word name, not the numbers.png that go with my file name, but I know that's the name. So if you have a different file name, you would put it in there. That's step one. All right. I've now executed decision. I'm getting rid of some of the extra lines of code because I want to be able to see more. All right. So when we create a new instance of this sprite, we're going to pass to it that word. Then my constructor function is going to be expecting a word or string to be passed to it. And it's going to then, oh, I already used file name there. I think file might be reserved, so I'll call it image name. And then I'll replace the hard-coded value with my value. So image name is the value that gets passed to the sprite constructor. So when you specify, I want a new instance of this class, and use the word sprite, being the name of our class, and then you have some parentheses, we can pass a value to that constructor function. So I'm passing a string, it's in quotes. My constructor function then is expecting a string to arrive, and then it can use that information here. So that if I had a second set of images with a different name, this code would now work. It's not hard-coded to that one single named file. So it's not hard-coded to alien. So if we run it, and it still works. So to make our class more usable, we're not always going to have 8 sprites. So if I want to be able to use the sprite class in more than one place and not have to keep changing every stinking thing about it, when I ask for a new instance, I can now pass in a value. I can pass in what I know is 8, which is how many frames I'm going to have. So inside my creating the new instance, I'm passing in the name and how many frames. Inside my Sprite constructor, now it needs to match with the same number of parameters. And now we can say number of frames, and then say total sprites is now equal to that number of frames. This now creates a more flexible, a more usable Sprite class that is now not having, so that way if you have two images, one is 12 frames, one is 30 frames, you could use the same Sprite class for both images. Otherwise, you would need to have Sprite 1 and Sprite 2 and Sprite 3 classes that are 99% identical with only a tiny bit of change between them, which isn't a good way to build your programming. Currently, our Sprite is tied to the mouse location. I want our Sprite just to be tied to an X location and a Y location. So if I'm going to reference values here, first off, that means I'm going to need numbers. So I'm going to have two floats, X and Y. And then we will need to provide values to those. We need to give it a value. In the beginning right now, we can set them equal to a random position so that our sprite will just appear somewhere on screen. Because when I change this to have 10 sprites, 100 sprites, or 1,000 sprites, or 10,000 sprites on screen, I don't want them all in the same spot. So we can set X equal to random width. Y is equal to random height. So that's going to just give me a random value based on the height and width of my sketch. Now, if we run this, we will see the sprite should show up somewhere on screen randomly. And we'll see there it is. If I run my sketch again, you will see that it shows up in a different location. So it's randomly positioning itself on screen. Now, what's not very fun about that is that he's not going anywhere. And in this particular animation, it feels like he should be moving horizontally across the screen. So really, what it seems like he should be doing is having an X going to the left by some amount. I'm just going to throw 5 in there. And his Y value, it seems like he's swimming horizontal, so he doesn't really need to have any change in Y. So I'm just going to leave the Y alone for now. But if I run this, we'll see that he now goes nowhere. My sprite doesn't move because when I look in my draw function, I just say display, but I never said s.update. So I never told it to call that function, therefore X is never going to be updated. So now I'm telling my sprite to update. That will change its X. I tell sprite to display, then it will show itself up at that X and Y location. Now if we watch the animation, we should see he flies off screen. It would be more fun that once he flies off screen, if he comes back and loops asteroid style. So if X is less than 0, then we can say X is equal to width. So that will now create a perpetual loop with my Sprite, so he will now keep swimming across the screen. Time to add in more than one of these into our project. So as we're going to add in more than one instead of just the single swimmer, we are going to need an array. We're going to need to then loop through this array, populate the array with a whole bunch of these sprites, and then we need to tell that array to update and display. So this is just like the catcher game in dealing with all of the falling balls. So that I will say Sprite, and then I will call this aliens, and it's an array. And I'm also going to have an integer here, which is my max aliens. I'm going to leave the previous two that we had there, and we're now adding in the name we choose is irrelevant. We just need to remember the name we're choosing. So now at this point, I'm going to say max aliens is equal to, and I'm going to start out with just a measly 10. It's not a good idea to put a ridiculously large number in the beginning until you verify your project is working. Once you know it's working, then you can do more with it. So max aliens is 10. And then we can say my aliens array is equal to new, and now it's filled with Sprite max aliens. So that now constructs a new array that has that many objects in it. The next step is to populate that array with a whole bunch of alien sprites. So this is where a for loop is useful. So we have for int I equals 0, semicolon, I is less than max alien, semicolon, I plus plus, close parenthesis, curly brace, and then now this is where we get to populate our aliens array. I'm just going to put an extra return in here for a little more space. So we've added in our aliens array that's going to be filled with sprite objects. We have an integer that is max aliens, the number that are going into our project. The advantage of using this system is when we want to update from 10 aliens to 100, I can just simply add a 0, and I will now have 100. That's why we want to hard code everything with variables instead of using fixed numbers. Because if I said aliens is new sprite 10, and then if we had 10 here, if I want to change it, I have to change that number in a couple places, and that's just no fun. So it's better to do it this way. And then we will say aliens at each position. We'll loop through our array is equal to new sprite alien. So each one of our aliens is now, so it's previously it's just like our line of s is equal to new sprite, but now we're making each object in my aliens array a new sprite object. So to get our aliens to update and display themselves on screen, what we need to do is we need to now loop through our array again. So we can just simply say what we want here. So we're going to loop through the array. I is 0, I is less than max aliens, I plus plus, and then I can say aliens I dot update. So we're calling it, so it's just like what we did for S, but now we're doing it for each object in the array. So that now loops through and shows it to us. Now that I have 10 here, I'm going to go up to 1,000. And we'll find out if it can run.
Won't.
Now, the thing about this and why it takes so long is it's loading all of that into memory, and then it's trying to do something, and we can see it ran out of memory trying to load 1,000 of these sprites, and it's still trying, so it's still freaking out.
Try 582.
No, try 583, then 582.
And we're stuck. Going at different speeds, what this means is inside our alien class, it's updating its position based on a hard value, that 50. I'm referring to my X movement, so I'm going to change that to speedX. If I run it now, I'll get an error because speedX has not been defined. But we can define speedX by setting its variable inside the sprite variables, and then I give that value inside the sprite constructor. SpeedX is equal to random, and now I can choose a random speed, and if I want it to be between a certain value, I could say 2, 8, and that means random will return a number somewhere between 2 and 8. So that now means each one of my alien swimmers here will be able to show up with a separate speed. So some are going slower, some are going faster, and then I do have the one static one who forgot how to swim. He's been frozen. And then we can see some are pokey and then some are just being overrun by their neighbors.